Chapter 3 in our course on statistics will finally get us to our first code implementations. We will learn how to write code that allows us to generate our own artificial dataset and thereby giving access to an entire statistics playground. By doing so, we will immediately get at the heart of statistics by discussing the crucial difference between sample datasets and population datasets. In a sense, Chapter 3 will lay the groundwork both for code and for concepts for all of the subsequent chapters in this course. So let's get into the slides. When we think about statistics, we of course think about data, and therefore it's worthwhile to briefly go over the different types of data. You have visual data, think of medical applications or self-driving cars. You have audio data, think of your personal and home assistant, Google HomePod or Alexa. We have of course language data, which gets all of the attention at this point thanks to the boom in large language models. And then of course the largest group and the most general group is structured data. Think of, for instance, recommendation engines for Spotify or Netflix. Now, the most used form of structured data is tabular data, and you're probably already very familiar with it. Nonetheless, let's take a closer look into the tabular data. Almost all tabular data has the same basic structure. Rows correspond to observations and columns correspond to features. And to understand how this works, let's look at this simple example. This table contains data that we were able to collect from customers visiting our website, which has a web shop attached to it. Now, each row corresponds to a different customer, and each column corresponds to the behavior of this customer on our website that we were able to put into data. For instance, the source column indicates by which source our customer came onto our website, either a Google search or an advertisement. The number of clicks column indicates how many times a customer clicked on our website. And likewise, the time spent on our website in seconds indicates for each customer how many seconds they spent on our website. Now, the last feature column, the purchase column, is arguably the most important one because it's a Boolean column that indicates whether a specific customer on this row made a purchase or not. The data in this table can be quite valuable. You can imagine that we might be able to discover a pattern between customer behavior and whether he or she will make an eventual purchase. We might even be able to identify a singular feature or behavior that has the largest predicting factor for the eventual purchase. If we, for instance, look naively at these three rows, then we see that customer B, the only one that made a purchase, was the only one that came through advertisement, and therefore we might be inclined to double down on advertising. So how do we now implement this tabular data into code? Well, as a data scientist, you will do almost all of your work, your data cleaning, your modeling, and your analysis in the Python programming language. And within Python, the library that is most used for data scientists is the Pandas library. It is a library built on top of Python that provides you with the majority of the tools you will need to work with your data. And the central object within the Pandas framework is the Pandas data frame. And this data frame will be the implementation of the tabular data. Rows correspond to observations and columns will correspond to features. Now, even though Pandas is tremendously useful, it also has some limiting factors. For instance, if you want to make some custom visualizations, or more crucially to this course, if you want to implement some more complex statistics, then the Pandas data frame is not the optimal choice. Instead, for these scenarios, we want to use Python arrays, and that's also the choice that we will use throughout this course. Now, don't despair if you're much more familiar with Pandas data frames, or even if all of your projects are revolving around Pandas data frames, because it is very straightforward to transform between the Pandas data frame and the Python array. And to see how this works, let's dive into the code. Before we dive into the code itself, let me remind you that all of the code in this course is freely available to you, either to use in your personal projects, but also in your professional work. The only restriction is that if you use it for educational purposes, you are required to reference this course. Now, all of the code is available to you in two ways. There is one very large Jupyter notebook file containing all of the code of the entire course. Now, because it's so large, it might be laggy depending on your own specifications. Therefore, there are also smaller Jupyter notebook files, one for each chapter that contains code. And with that out of the way, let's now really dive into the code. This first cell is a familiar cell. It's just importing the packages that we will need. We can see Pandas, we can see matplotlib for visualizations, and NumPy and so on. So you can just run this and forget about it. The second cell is also a background cell. It's just there to change the defaults on the visualizations. For instance, changing the font or the font size. So you can also just run this cell and forget about it. And then we get to the main cell. In this cell, we will look at the conversion between a Pandas data frame and a Python array and how to change between the two. The first direction that we will look at is transforming a Python array into a Pandas data frame. Now first, we define of course our array. Simply type np.array and provide it with a list. Now, as is the case with a list in Python, the order matters, and thus the Python array is an ordered object. So we make two arrays, and what we want to do now is to make a data frame with two columns, the first column being the first array and the second column being the second array. And this is very straightforward. We define our data frame and we put it equal to pd.dataframe, and then we provide it with a dictionary. The key in our dictionary will be the name of our column. In this case, column 1 will be called column 1. Then the value for this key will be the Python array. And the same for column 2, which will be called column 2, and then the values will be array 2. And at this point, we have a data frame with column 1 and column 2 as the column names, and the corresponding values will be the Python arrays. Now we can save this data frame as a CSV just by putting df.toCSV and giving it a name. Now what is probably more relevant to you is the other direction, going from a data frame to a Python array, because most of your projects will probably already work with Pandas data frame, or your data will be saved as CSV files. So how do we do this? Well, first we load our CSV file into a Pandas data frame. So just dfloaded is equal to pandas.readCSV and then the name of our CSV. And then we want to make two Python arrays, one for each column in our data frame. And this is also very straightforward. So array column 1 is equal to our data frame dfloaded. Then we single out the column that we want, in this case column 1, and then we add dot to numpy. And this will give us a numpy array or a Python array for column 1. The same can be done for column 2, and we are done already. Now, to see this all in action, we can of course display the data frame that we loaded. And remember, this data frame that we loaded is the exact same data frame that we wrote away, the data frame that we made by using two Python arrays. And then we can also show the arrays that come from this loaded data frame. So you can run this cell, and indeed you see first the data frame that we made from two Python arrays. Array number 1 will be the first column, and array number 2 will be our second column. And then from this data frame, we made two new arrays. And again, we get the same arrays as before, because of course the columns were the same as before. And this is how you can easily convert between the two types of data. And therefore, all of the tools and the visualizations throughout this course can be very easily applied to your own data, even if you're working with Pandas data frames.